Hello, in this video we're going to work through this question here. So a tree grows vertically on a hill which is inclined at 10 degrees to the horizontal. The tree casts a shadow of 20 meters up the hill. If the angle of elevation of the sun is 35 degrees, find the height of the tree. So when working through these questions, again, when I'm working on paper, and I did this a lot in university, I actually color-coded all my answers, and I always carried highlighters because I'd make silly mistakes. I'd actually go through and highlight the key values and key terms. Again, this is going to change from person to person, but it helps me avoid copy errors. So with this question, I have to draw a picture. And the key thing with drawing this picture is you draw this picture nice and large. So there's my ground. There's the hill. Okay, actually, let's draw that hill again because that looks more than 10 degrees. That looks a little better. Okay, and it says the tree grows vertically on the hill. Now, a lot of times students will draw the tree right at the base of the hill. Even though in this question it would be fine, I always like to draw the tree a little ways up the hill, just because it allows me to work if something happens. It allows me to accommodate different cases. So unless the question specifically tells me the tree is at the base of the hill, I draw it a little bit up the hill. And it goes vertically, so it should be 90 degrees from the horizontal, not 90 degrees from the hill. And so now it says the sun casts an angle of elevation. So with this, you have to imagine where the sun would be. And the sun would probably be somewhere around here. There's my sun. You don't need to actually draw this, but there it is. And again, we think of rays of the sun essentially like a straight line. And so it's going to go across the top of the tree, and it's going to intersect right at that point there. So this is kind of like my sunbeams. So therefore, this is going to create an angle of a shadow here of 20 meters up the hill. Okay. So now the question comes, well, what do I need to solve for? Well, we're interested in the height of the tree, and so let's call this point H, and let's call this point I don't know, J. Let's call this point K. We'll just give them names just for our discussion. So let's fill in the rest of the information that I know. I know that it has an angle of elevation of 10 degrees, so that we know. We know the sun has an angle of elevation of 35 degrees. Now this is a point that we need to just really watch ourselves, because remember, the important thing with angle of elevation is that it's measured from the horizontal. So if I'm measuring the angle of elevation from here, I'm going to draw just a little crosshatch here. And that helps me kind of figure out my angles. And from this, I know that we have 35 degrees there, and we see we have a Z pattern here. So we see this is 10 degrees. So therefore, I can say angle H is equal to 45 degrees. Now let's find angle K. So again, I'm going to draw a little crosshatch there. And I can figure out that the angle in here is 10 degrees using just angle argument. We can see we have a Z pattern here. That's 10, and then an opposite angle. And so therefore, in here we have 80 degrees. So angle K in the triangle is 80 degrees. And we can use just simple mathematics, 180 minus 80 minus 45 to get angle J, which is 55 degrees. And so now I need to find the height of H. Now a little organizational thing, you might have noticed I drew my diagram on the right side of the page, not the left side of the page. Typically when we write, we go from left to right. What you don't know is that I'm left-handed. And so one of the things I always did when I was in school, and I still do this today, is left-handed people typically cover up their works. So that led to a lot of copy errors because I was covering up what I had written. So often I'll work from the right side of the page left. So that's why I drew the diagram here, because what that means by drawing the diagram on this side, when I do my math over here, I can see the diagram and I don't have to keep lifting up my hand. Little tricks like this are really useful, especially in a test writing situation, and I imagine a lot of you will be writing a number of tests going forward. So let's take a look at my diagram. So I'm trying to find clues to what I do, and sine law is used when I have a pair, I have an angle length pair, so that means sine law is a possibility, provided I have the angular length, one more angle or one more length. So I do have that angle, and that's across from h. So therefore I can set up sine law here, so h over sine of 45 degrees, don't forget that degrees symbol, is equal to 20 over sine of 55 degrees. Don't forget that degrees symbol. So h is equal to 20 times sine of 45 degrees. For those of you that have watched my other videos, they probably sound a bit like a broken record now. But again, remember, sine of 45 and sine of 55 are just numbers in disguise. So you can treat them just like if it was h over 6 equals 20 over 9. I write sine over 45 just like a number, and what that means is I can keep my calculator off to the side until the very last step when I need to actually type this in one step. So I'm going to say 20 times sine of 45 divided by sine of 55. And I see I get a length of approximately 17.26 meters. So now I can say therefore the tree is 17.26 meters tall. So now my question for you is, and again, whenever you're doing this, you always stop at the very end and you say to yourself, does this make sense? Okay. And in this case, I would say yes, it does, because 55 degrees is opposite of 20, and that means h needs to be less than 20, but it's going to be pretty close because angle h is 45 degrees, which is less than 55 degrees. I hope this helped.